Hello class, this is the lecture for Chapter 6 on additional database objects. We're going to go ahead and jump right into it. In this chapter, we're going to be learning about three additional database objects. The first one being sequences, the second being indexes, and the third being synonyms. We're primarily going to focus on sequences and synonyms in terms of what we do with our Oracle SQL database, and we're actually running queries and DDL, DML commands to create the synonyms and sequences. I'm not going to have you guys create indexes, although you're more than welcome to do the examples in the book if you want to. But in terms of indexes, we're mainly going to just talk about what they are, what their purpose is, why they're useful, and but then with the sequences and the synonyms, we're going to go ahead and actually run commands on those. So let's go ahead and jump into the PowerPoint here. And again, I'm going to go through the PowerPoint, and then I will stop and we'll open up SQL Plus and run through some examples of how to make sequences and how to create sequences and how to create synonyms. So let's go through the PowerPoint presentation. These are just objectives on what we're going to do for the chapter. Again, we're going to focus on the sequences, the indexes, and the synonyms. So here is just a rundown quickly of some of the different database objects in Oracle. So obviously we have tables, they store the data. Then we have these sequences, and sequences are going to generate sequential numbers. We'll talk more about that in a minute. And then we have an index. Indexes allow users to quickly locate specific records in the database, so it will speed up your queries significantly. And then synonyms are aliases for other database objects, which make them where you can quickly reference them, or if you want to change the name of a table or another database object, you won't necessarily have to change it in your application code if you use a synonym. So those are the three that we'll be talking about. The first one up are sequences. Sequences are extremely useful in Oracle. So the primary purpose of a sequence is to generate a unique value for a primary key column. It can be used for other purposes as well, but in practice, most of the time, the sequence is going to be used to generate a unique number so that you can have a primary key. They're used internally. It's for internal control. So most of the time, the end user of an application is not ever going to necessarily see a sequence. A lot of times, whenever you're creating your table in your database, you just want to generate an integer that serves as a primary key that you can reference. For example, if you had a sales system where you were taking orders, kind of like the Just Lead Books database, but let's say you had invoice numbers. So every time someone came into your store and ordered something from you, you may want to generate a new invoice number or a new receipt number for that customer. And in the database, what you can do with your application is use a sequence so that every time you start a new invoice or have a new order for the customer, it automatically generates a new invoice number or order number automatically. And so yeah, that's the primary purpose of a sequence. One other thing that the sequence does allow you to do is have some business and auditing controls. So with a sequence, when these numbers are automatically generated in your database, that is a way that you can control the numbers and for example, the order numbers or the invoice numbers that are being generated in your application. That way you know that people aren't just creating their own invoice numbers or order numbers, the database is going to control that for you so that you know that it's always going to be a unique value. Okay, so let's look at how we actually create a sequence and look at the create sequence statement. So you can see here in this screenshot the create sequence command as well as the different options that you can specify within the create sequence statement. So let's start with the first line. Create sequence is the command to actually create the sequence, and sequence name is going to be the name that you give your sequence. So usually we kind of follow the same sort of naming convention that we used for when we created constraints, and you'll want to do something like table name underscore column name underscore seq for sequence. That's generally the guideline that we'll follow. So after you create and obviously if it's a database object, like just like a table or any other database object, it has to be unique. So your sequence name always has to be unique, and that's how you generally create the create sequence. So the next line here, increment by within and then a value, basically tells you this is how we're going to increment this sequence. So by default, the value for increment by is 1. So whenever the sequence generates, the very first number, let's say that it has, is 1, and when the sequence is called again, the next number will be 2, and then 3, and then 4, and then 5, and so on. So it's going to increment the values by 1. If you wanted to increment the values by 2, and say the values go 2, 4, 6, 8, 10, 12, 14, and so on and so forth, you could specify it that way. If you wanted to do it incremented by a value of 10, you would say increment by 10, and then the sequence would be 10, 20, 30, 40, 50, 60, 70, 80. Again, the default value is 1. The next line is the start with value. So if you want your sequence to not start with the number 1 or the number 2, you can specify exactly what value the sequence starts with. So if you want it to start with 4,870, you could say start with 408, whatever number I just said. You can start it by whatever value you want the sequence to start with. So for example, if you had the increment by as 1 by default, and you started with 500, the sequence would go 501, 502, 503, 504. So it would start with 500 and just go on by whatever increment by value you've specified. So start with it just tells you what value you want the sequence to start with. The next two lines are the max value and the min value. If you don't, and by the way, if you don't specify, when I say that by default it's going to be, the increment by is going to be 1, it's defaulting whenever you don't specify these options. So these options are not something that you have to put in the create sequence statement. It will default to specific values if you don't put these in. So it will default to 1 for increment by. It will default to 1 with start with. Same with max value and min value. So you can specify a max value. Let's say you only want your sequence to be able to go up to 10. So it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it reaches 10, that's the top number that the sequence will do. Same with the min value, because sequences can go either way. And I guess let me back up. I guess I should have mentioned that the increment by can go up, so it can increment by 1 or 2 or 3. It can also increment negatively or go down by -1, -2, -3, etc. So if you wanted it to go from starting with 500 and then go down to 0, you could make it start with the value of 500 and increment by -1, and then it would go 500, 499, 498, 497, etc. So you can set min values. So if you only wanted it to go down to 100, you could specify that min value and it would go down from there. So again, min value, max value. If you're obviously if you're have negative increment by numbers and you're going down, the min value is more important. If you're only going to have positive numbers, min value doesn't necessarily matter. So by default, it's going to do no max value, no min value. So if you don't specify these, they're just going to assume that there aren't any max values or min values. Oops, sorry. The next line is cycle or no cycle. By default, again, it's going to be no cycle. But if you specify cycle as an option, what that will do is it tells the sequence when you reach the max value of the sequence or the min value of the sequence, cycle the numbers. So let's say you have a sequence and you're going to start with 1 and the max value is 10. Once it gets to 10, the sequence will cycle and it will start over back at 1 again, or whatever your start with value is. So it will cycle through the numbers again. So this will obviously be a problem if you're using your sequence as a primary key, because with a primary key you can only have unique numbers, and if you cycle the numbers and it starts to try to reuse the same numbers over again, you're going to run into errors with your primary key. So most of the time you're going to leave this as no cycle, and then just continue to use numbers all the way until the max value is reached. If the max value is reached and it can't, and you don't have the cycle option turned on, Oracle is going to throw back an error and tell you that you need to reset your sequence basically because you've reached the max value. And then the last two options, order and cache. So order, by default, it's going to be no order. If you do specify the order option, that is going to tell Oracle to return the values in the order in which the request was received. So if you are in an environment where you have multiple users who are going to be generating values using this sequence at the same time, you may want those sequence numbers to happen in the order in which the database receives them. So you may want to specify in that situation, you may want to turn on the order option so that the sequence goes by whichever request it receives first. By default, it will be no order, so the sequence may go out of order based on when they were requested. And then the final option, cache, by default is no cache, but you can turn the cache option on and specify a value. And what that does is Oracle basically prefetches a block of numbers. So if you had a cache value of 50, it would go ahead and set aside 50 numbers to be used, and that will help generate the numbers a little bit more quickly. By default, the no cache option is going to be turned on, and Oracle by default is going to it defaults a cache value of 20. I'm sorry, I shouldn't say that the default is no cache, but Oracle by default will do a cache value of 20, meaning it will automatically grab 20 numbers and assign 20 sequential values and put those in memory for the users to have access to. So those are the different options. That's create sequence, and those are the different options for that you can specify for the sequence. Okay, this is again some of the information that we've already been over. You can specify a min value for a decreasing sequence and a max value for an increasing sequence. Numbers can be reused if cycle is specified. The order clause is used in an application cluster environment. So again, if you have multiple users, using your application, you may want to turn on the order clause for your sequence. And then cache is used to pre-generate integers, and the default is 20. So it will automatically grab 20 sequential numbers. Okay, let's go ahead, and I'm going to open up SQL+, and we will walk through the same examples that they have in the book. So I'll go ahead and connect as my Scott user. And let's go ahead and create this sequence. So I'm just going to type the same example that they have here in the PowerPoint and in the book. We're going to do a create sequence. And again, the naming convention is, by the standard, would be table name, orders, underscore, order number. So we're going to create a sequence on our order number field. So anytime a new order comes in, we're automatically going to generate an order number for it. That's going to be our primary key as well. And then I'm going to do underscore SEQ for sequence. That way, when I'm looking at a list of database objects and I see underscore SEQ, I know that it's a sequence. I'm going to specify my increment by as 1. So every time this sequence is called, it's going to increment the number by the unique value, or the integer, by 1. And then I'm going to specify the start with as 1021. So the sequence is going to start at 1021, and the first time it's called, it will be 1022, 1023, so on and so forth. I'm going to specify no cache option, which means numbers will not be pre-fetched into memory, and no cycle, so that the numbers are not going to be reused. They're not going to be cycled over again. And there, my sequence has been created. And if from here, once I see it is created, I can actually query the user sequences table to actually see some more information about the sequence. And so that way I can know what the min value is, what the max value is, what the increment value is, and actually even what the last number was, so that I know what the next number in the sequence should be. Now when we start to use SQL Developer, this is going to be much easier to see. But for now, in SQL+, again, I'm just trying to get you guys to understand, the bare bones SQL commands. But again, in SQL Developer, when we use that in a few weeks, you'll be able to pull up these database objects and sequences in particular and see this information very quickly without having to remember all of the control tables such as user sequences. But if I do a select star from user sequences, and again, I know this is hard to read, but it's giving me my sequence name that I just created. The min value is 1. The max value is this number. It's basically 999999999. It's a very, very large number. Increment by 1. The cycle, which is the C column, is no. The order option is no. Cache size is 0. The reason why the cache size is 0 is because I put no cache on. And then the last value, the last number, is 1021. I haven't called the sequence yet, so the last number is still 1021. Now, the next thing we're going to talk about, the book refers to them as pseudo columns. So how do we, when we're writing a query, how do we call the sequence to actually have it generate a new number? There's 2 pseudo columns that we can use for sequences. One is called nextval, N-E-X-T-V-A-L, and the other one is called curval, current val. So what nextval does is whenever you call it in a query, the nextval will generate a new number for the sequence based on what is set in the increment by and what the last number is that's been used in the sequence. Curval is going to allow you to see what the current value is of the sequence. So let me go ahead and back to the PowerPoint quickly. Okay, here's where we were looking at the user sequences table. And then here is an example of how we use next val. So here's an insert statement where, as an example, in our if we had an application that was generating order numbers and we wanted to insert a new order into the orders table, and you can see in the values clause here that for order number we are calling our sequence orders underscore order number underscore sequence dot next val. So what that's going to do is take whatever the value is, the current value of the sequence is, and generate the next number, and then it will insert that into our orders table. Current val, excuse me, so the current val, the cur val is going to again store whatever the current value is of the sequence. So in this example, we're inserting a record into order items, which, if you remember in our justly books database, you have orders that has the basic order information, and then you have order items, which actually gives us some details about the order, such as the ISBN number, quantity, etc. So as an example, if you're creating a new order and you use the next val to create a new order number, and then you want to make sure that you insert that same order number into the order items table, before you generate another value, you could always use cur val, and then that way you insert the current value of the sequence into the table. Now, if you use next val before you do this insert statement, you're going to be out of order. So if you're going to use this method, you would need to make sure that both insert statements were run sequentially, so that before the sequence was called with next val again, that would throw the sequence out of order in the two tables. Hopefully that makes sense. So let's go back to SQL Plus, and we will try and use the next val and the cur val options. So one of the ways, I'm not going to run this insert into statement. What I am going to show you is a quick way that you can check sequence numbers and check what the current value of a sequence number is, and also how you can do a next val quickly. And that's by using the dual table in Oracle. So the dual table is basically available if you're going to perform a query that's not retrieving data from an actual table. So you can actually do select high from dual, and it's just going to return whatever I select high. So using dual, we can actually create or actually call the sequence that we created and see what the current value is, and then call the next val. So if I say select orders underscore order number underscore sequence dot cur val from dual, hang on, let me check this. Yes, so the cur val, my fault, the cur val is not going to give us anything because we have not done a next val yet to actually generate a number in the sequence, so there is no current value in the sequence. So let me back up, and instead of doing cur val, let's select orders underscore order number underscore sequence dot next val from dual. And then, so the next val is 1021. Let's call it again. Now the next val is 1022. Call it again. Now the next val is 1023. And if I do cur val instead, again it shows me what the current value of the sequence is, which is 1023. And if I also select off from my user sequences table, can't type tonight, it will show you the different values in my sequence. So that is a quick way that you can check you can call the sequence by using nextVal and curval. So again, anytime you're writing a query, such as an insert into, or even an update, or a select statement, you can call the sequence using nextVal or curval as the pseudo columns. So you can also use a sequence to set a column default value. So this is just showing when you do a create table command, you could set the default as a sequence with using the nextVal pseudo column. So that way, anytime a new record is inserted into the table, column 1 in this example will automatically default to use the sequence value. So whenever we create the orders table, what we could do is set a default for the order number column to use our sequence, and that way it will just automatically generate a new order number using that sequence. We can also change the sequence. Much like altering a table, we can alter the sequence using the alter sequence command. So we can change most of the options, such as the increment by. So you can change it from incrementing by 1 to incrementing by 10. The start with value cannot be altered, so you can't change the value that you start with. The only way you can change that is if you completely drop the sequence and then totally recreate it. And the changes cannot make current integers invalid, so you can't change the increment by or any of the other options to make it where the integers are no longer a valid option. Here's an example of an alter sequence command. Pretty basic. Alter sequence, the sequence name, and in this one we're changing the increment by to increment by 10 instead of 1. And then the last command is if we're going to remove a sequence, we drop it using a drop sequence command. So if I say drop sequence orders order number sequence, the sequence has now been dropped from the database, and it will no longer be in the user sequences table. And there's, again, the example. Creating an identity column, this is something that is new in Oracle 12c, where you can, instead of using a sequence to populate the primary key column, you can create an identity as the primary key. So instead of using a sequence, Oracle can now automatically generate the numbers. It's kind of crazy that it took Oracle this long to put that option in. It's been in SQL Server, MySQL, even Microsoft Access for years, and I'm not sure why it took them so long to add this option. I guess most people had gotten used to using sequences, but now if you just generate the column as identity, it will automatically generate the numbers. Okay, so the next database object we're going to talk about are indexes. Indexes are something that, if you are a database administrator, you're going to be focusing on these a lot, because indexes are what are used primarily outside of the developers who are creating the SQL queries. The database administrator is going to tell your developers, hey, if you're going to be running this type of query, you want to tune your query or write your query in such a way that it utilizes indexes, because indexes will help speed up the time that it takes for the query to retrieve the data from the table and return it to the application. So the faster we do that, the better. It also affects the disk I/O and the number of reads that we're having to do in the database. So if you have complex queries or queries that are querying a large amount of data, if you're not using an index, it will take a lot of memory on the database server and a lot of disk I/O to return that data. So we really want to utilize indexes to optimize our database, to optimize our queries, so that we can have much faster read times and get our data back much more quickly. So I'm not going to go into a lot of detail on indexes. Your homework for this chapter is primarily focused on sequences and a little bit on synonyms. You are going to have some questions on your quizzes and on your tests regarding indexes, but we're not necessarily going to go as deep into it as the book goes into it. We're going to keep it more on a high level. But delving into this a little bit here, Oracle by default, most of the time when you have an index in Oracle, it's going to be a B tree, which is short for balanced tree index. It's the most common type of index that's used in Oracle. This has an example of if you have a query that's searching for a zip code and how it uses the index to locate the record that you're looking for very quickly. So if a table has a column that has a lot of distinct values in it, so for example, if you had a customers table or an orders table that had zip codes listed, and there's a lot of unique or distinct zip codes, if you're trying to find a specific zip code, you may have to do an entire scan of that table to look through every single record and determine whether or not, in this example, if you're searching for a zip code of 90404, you may have to go through thousands and thousands and thousands of records, or millions of records even, to find zip codes that are 90404, and let's say there's only 100 of those. So there's really no sense in having to scan and look at every single row of a table that has millions of records to find, let's say, 100 values that are 90404. It's going to take a long time to do that. So instead, we're going to create an index. And when you create this index, the database basically behind the scenes is going to map out using row IDs to put all of the zip code records in order, so it makes it much easier for the database to quickly locate records that are 90404. So you can kind of see what it's doing here is it'll quickly say, okay, is the zip code less than 45,000 or is it greater than 45,000? If it's less than 40 or greater than 45,000, which this number is, it goes down a little further. Okay, well, is it greater than 83,000? Okay, it is. So then it goes down a little further, and then eventually it will get to the row ID where 90404 is. And you can see that these numbers go from smallest to largest, and they're assigned a row ID internally in the database. So the database can quickly go, boom, I'm going to grab all of the 90404 records right here because I can quickly get to them because they're indexed. An index, you can think of it like an index in a textbook. So if you want to search for the word query in our textbook, that's going to be a million different places, right? But if you have an index, if you go to the index in the back of the book, the index will tell you what pages the word query, I don't know if that's really true. If it has query in there, I would kind of be surprised. But let's say there's I'm trying to think of it. Look at a different one in our book here really quickly. Create sequence, for example. Create sequence is probably on a bunch of different pages in the book, but if you look that up in the index, it will tell you exactly which pages it appears on. Same principle for an index on a database. If I'm going to look up something in a table, I can use the index and you can quickly find exactly where it is physically located in the database and return that result to you very quickly. Indexes are implicitly created when you assign a primary key to a table. So if you have unique values and a primary key, obviously every value is going to be unique. You have a high cardinality. So if a column has a large number of distinct values, that means it has a high cardinality. So if the cardinality is high, you want to really think about putting an index on that column. So again, primary key, it's always going to be a unique value. So Oracle will automatically create an index on that primary key. Indexes, by the way, can be done on multiple. You can have an index on multiple columns, combined columns, just a single column. So there are a couple of different options there. It's explicitly created if you want to use the create index command. So I'm not going to go to SQL Plus and do this, but just so you know, it's very basic. Create index, index name on the table name, and then the column name. So in this one, we're going to create an index on the zip code table. I'm sorry, on the zip code column in the customers table. So you can also create, here is an example of one where you're creating it on two columns. So if you know you're going to have a lot of distinct if you're going to have high cardinality on the first name, last name combination, you can create an index on both columns combined, so that if you want to quickly look up someone's name, you're not going to have to scan through millions and millions of names to find this one person's distinct name. So that's really the beauty of an index. The book is going to go into more details about the explain plan and how you can actually look into the details of whenever you run a query, and you can do an explain plan that will show you if the query utilizes the index or not. It's good for developers who are trying to optimize their queries and make sure that they're returning values and utilizing indexes the appropriate way, but we're not necessarily going to get into that. Bitmap index is just a different type of index that uses bitmap. Function-based indexes, similar to a B-tree index, except instead of using a column, we're using functions. So if you have some sort of calculation that you're doing, such as retail minus cost, you can create an index on that. So let's say on the books table, we want to have the profit. We want to put an index on the profit, which profit is retail minus the cost, the retail price minus the cost. So we can put an index on that. So whenever we're running that function or doing that calculation, Oracle can quickly find those values for us as well. So that's a function-based index. Indexed organized tables, IoT. It stores the table contents in a B-tree index structure. Again, something you don't really need to know a lot about, but here is an example of the IoT, the organization index option in the create table statement when you're building an IoT, an index organized table. Verifying index, so there are tables in Oracle where you can actually look up the indexes. Again, when we get to SQL Developer, you'll be able to see indexes much more quickly and easily. But this is, if you query the user indexes table, you'll be able, and then specify a table name, you'll be able to see all of the indexes that are on that table and what the index type is. this is the user individual columns table where you can actually kind of the same thing. You can see what the column name is that the index is referencing. So again, if you look back to our example, there's the zip code, and then the customer, the last name and first name is used by the same index, customer name underscore IDX. And so that's it for indexes. Now we're going to move into the third database object, which is synonyms. So I mentioned this at the beginning of the lecture, but synonyms they're a permanent alias for database objects. So I believe we've talked about how you can alias a table in Oracle. So if you were doing a select query and you wanted to say from customers, you can also say select all from customers C. And whenever you do C, that's basically giving you an alias for the customers table. So if I wanted to say select C dot last name from customers C, I can utilize the alias C dot and then the name of the column that I'm selecting. So it's just a way to shorten down the name of a database object, or in this case a table. Whenever we talk about joins, and when we're using joins, it makes it very easy to reference tables in your select statement if you just shorten them down with a letter or with some other alias. That way you're not having to say select customer dot last name, customer dot first name. You could just, if you're using an alias of C, you can just say C dot last name, C dot first name, and it makes it much more efficient. So synonyms are the same thing, but they're permanent. So you don't have to specify it every time you do a select query. You can actually create a synonym. I could call customers table C if I wanted to, create a synonym called C, and then I just have to reference it as C from now on in all of my queries. So here is, and really quickly, there are two different types of synonyms, private and public. Private means it's only available to the user who created it. So if I created it and by default it's going to be private, I'm the only one who can use it. If we make it public, that makes it available to anyone who uses the database. So here's the syntax: create synonym, the synonym name for, and then whatever the object name is. So you can create a synonym for pretty much any database object. In our example, we're going to create a synonym for the orders table. So instead of calling it orders, we can just call it order entry. So let me hop over to SQL Plus, and if I say create synonym order entry for orders, synonym created. Now select star from order entry, where customer number equals 1010. And so there you can see I referenced the synonym instead of the orders table, or instead of the order. The orders table. So if I say select all from orders, where customer number equals 1010, it gives me the same values. So now I have a synonym and I can reference it just like the regular table name. If I want to drop that synonym, very easy. I can just say drop synonym order entry, and now it's gone. So now if I try to select all from order entry, it says it does not exist. That is pretty much it on synonyms. And again, one of the reasons why synonyms may be used is, let's say I created this order entry synonym and I referenced it in the code of my application, and then if I ever wanted to change the orders table and call it orders new, I wouldn't have to change my code because I would just have to change the synonym, and then I wouldn't have to change my code. I could just change the synonym to use orders new instead of orders, and then I wouldn't have to change the code in my application. So that's one other advantage of us using a synonym. Okay, so I think that is about it. Just again, to wrap it up, we discussed sequences, which were used to create unique values in our tables. We discussed indexes, which create an index similar to what you would see in a textbook to allow you to look up data much more quickly when you are querying your database. And then the third were synonyms, which are used to create an alias for your database objects so that you can reference them in a different way. So if you have any questions, again, please email me, and I will talk to you soon.